Hello, everyone. Mr. Sutherland here. I hope you guys are doing well as we're finally here in the month of May. One more month left of e-learning to close out this year. What we're going to do today is we're going to look back at graphing quadratics from a new form. If you remember earlier in chapter 8, we did standard form of a quadratic and vertex form of a quadratic. Now we're going to see what information we can get from the factored form. And so it connects a lot of the things that we've done so far together. And it's going to bring back some things that we haven't talked about in a little bit. So we're just going to do two examples. That's going to be it. And then you're going to have a worksheet with 4 problems that'll give you a chance to practice this. So here is our first problem. So we're going to have f of x is equal to x squared plus 2x. Actually, I'm going to spread this out, move this over just a little bit more to the middle. F of x equals x squared plus 2x minus 8. And so right now that quadratic is in standard form. And if you remember from standard form, we had a way we could find the vertex using opposite of b over 2a. Also gave us the axis of symmetry, and we could find the y-intercept. But now what we can do is let's go ahead and let's put this in factored form. And all that means is that I'm going to take this and we're going to write it in factors instead of a standard form. So we're going to factor this. So what multiplies to negative 8 and adds to 2? So if I do my little list up here, since I've got negative 8, I've got negative 1 and 8, or 1 and negative 8. And then I've got negative 2 and 4, 2, negative 4. So here is my group that adds to be positive 2. So my factored form is x minus 2 and x plus 4. Now, once we have the factored form, the first thing we can now find the zeros. And remember, on our graph, those represents our x-intercepts. So remember to find our zeros. This is what we did on Thursday's notes, is I'm setting this equal to 0, so I know x minus 2 equals 0, or x plus 4 equals 0. So we add 2 to both sides on this one, so we get x equals 2, or if I subtract 4 from both sides here, we get x to be negative 4. So my zeros are 2 or negative 4. Now I'm going to go ahead and I'm going to bring in a graph screen here. I make that a little smaller and move it up here. So here's what we know about our function so far. We know we have a 0 or an x-intercept at 2. And we have an x-intercept at negative 4. Now, the next thing I want you to find is the axis of symmetry. Now, here's where we're going to think a little bit. Remember, that axis of symmetry is a vertical line. So let me just draw an example here. If I have a parabola, it's this vertical line that cuts our parabola exactly in half. So if I know a point over here on my parabola, if I know A, and I know a point over here, and I know B, I know this axis of symmetry is halfway in between those. So to find that, what we're going to do is we're just going to add those 2 points and divide by 2. We're finding the average of them. Well, we have 2 points here. I have the 2 zeros. So I'm going to take the zeros. I'm going to take negative 4 plus 2 and divide by 2. So negative 4 plus 2 is negative 2 divided by 2. That tells me my axis of symmetry, remember, would always start with x equals, is x equals negative 1. And so if I go to negative 1, I'm going to change colors. And if I draw my axis of symmetry, and it's pretty clear that that is halfway between my 2 zeros. So there's your axis of symmetry. And now the last thing I want to do is I want to find the coordinates of the vertex. What we know already is that the x-coordinate of the vertex, remember, is always whatever the axis of symmetry is. So since the axis of symmetry is -1, so is the x-coordinate of my vertex. Now to find the y, I'm going to plug -1, and I could plug it into the original one. I'm actually going to plug it into my factored form one. It's a little bit easier to deal with because, and I'll do this work over here, that means f of -1 would be -1 minus 2 times -1 plus 4. So -1 minus 2 is -3, -1 plus 4 is +3, so we get -9 for the y-coordinate of our vertex. So now I can go down here and make a point at -1, -9, and I can sketch a graph of our parabola. So it's really, factored form is just a new form, but it's not that different than other things we've done. It's just from that form, we can quickly get the zeros, we can quickly get the axis of symmetry, and we can get the vertex. So what I'm going to do is I'm going to start with number 2. And number 2, I want your function f of x to be x squared minus 3x minus 10. And so what I would like you to do is do the 4 things I did above. Write it in factored form, find the zeros, find the axis of symmetry, find the coordinates of the vertex, and then sketch a graph of it. And you can pause the video, and when you're done, come back and I'll go through it with you. Okay, so let's see how you did with this one. So again, I'm going to go ahead and I am going to, I know you guys can't do this little cheat code here. I'm going to get my graph kind of set up over here, ready to deal with later. Not really right now, but we'll deal with it as we go along. So the first thing I wanted you to do is write this quadratic instead of standard form, write it in factored form. So to do that, we just have f of x equals, now it multiplies to -10 and adds to -3. So I have -1 and 10, 1 and -10, -2 and 5, 2 and -5. So there is my group. So that factors into x plus 2, x minus 5. So there is my factored form. That's the first thing I wanted you to do. Second, find the zeros. So remember, the zeros just mean we're pretending that this x plus 2 times x minus 5, if I'm finding the zeros, I want to know when does this equal 0? And this is what we did again last time. So now I have x plus 2 equals 0, or x minus 5 equals 0. So subtract 2 from both sides. I get x equals -2, or here I'm going to add 5 to both sides. I get x equals 5. So I get -2 or x equals 5 are our zeros. So at -2 on the x-axis, I'm going to put a point, and 5, I'm going to put a point. Okay, next, axis of symmetry. This was kind of the new piece for today. And remember what we said, the axis of symmetry has to go halfway between these. So what I do in order to find that is I just take the 2 zeros, I add them, and I divide by 2 to find the halfway point. So that becomes 3 over 2, which is 1.5. So x equals 1.5 is our axis of symmetry. So if I go to 1.5 and I draw a vertical line, kind of dotted or dash, you can see that's exactly halfway in between. And finally, we want to find the coordinates of our vertex. And the first part of our vertex we know has to be 1.5, because whatever the axis of symmetry is, that goes here. And now to find the y-coordinate, I'm going to use that factor form again. I'm going to find f of 1.5. So I have 1.5 times 2 times 1.5 minus 5. So that becomes 3.5 times negative 3.5. And so if I do that, 3.5 times negative 3.5, I get negative 12.25. So there is the y coordinate of my vertex. And then if you know this, you don't have to remember that little formula opposite of b over 2a. It gives you something that you can use no matter what, as long as it can be factored. And then I'm going to go ahead and sketch in, and there is our parabola. So last class, let me go back to the notes here, we worked on finding the zeros of a quadratic by factoring. And so what we're doing today is we're giving you a quadratic in standard form, factoring it, using what we did last time to know finding the zeros means I set that equal to 0 and I can find my x-intercepts. And then finding the axis of symmetry by realizing that's the average that's in the middle of my two zeros that are here. So I just add them up and divide by 2. And then I plug in to get the y coordinate of my vertex. So a little bit more with graphing, a little more that we can do now that we know more about factoring and zeros. I hope you found this helpful. If you have any questions, do not hesitate to contact Ms. Musa or myself, and we'll talk to you again soon. Take care, guys. Bye.